Is it on? Yeah. Good afternoon. As Ron said, we're going to talk about interactive analytics of billions of events that we collect on a daily basis. But before we go into the actual talk, I want to go back probably a year back in time, about the exact same time of the year, last year. We were struggling. We working on a new system. And with all these emerging cloud technologies that came out, especially in the area of big data and big data processing, we're thinking maybe we should try out some alternatives in that area and see where we can get with that data. This was the first step in our journey that I'll share with you in this talk about how to process the data and where we started and what we learned and where we are today. But before we start, let's give a brief background about what Seismic is doing. And the company is Seismic. I know it's hard to pronounce, so at least I hope this is one thing you get out from here. We are working in the ad tech world. And in a simplified view, ad tech is divided into two parts. We have publishers on one hand. They have real estate of websites that they are renting or giving away to advertisers to put their ads on that page. They are basically selling their inventory. They're selling their pages for advertisers that pay to put their ads on these pages. There are many types of ads and many mechanisms. We will not talk about that, but just to give you a bit of a view what is advertising in reality, not that simplified. You can see this chart of about the different companies. You can see on the left side are the advertisers, on the right side are the publishers, and all set of companies that are in between. It's a very crowded space, many technologies, many systems or tools that are involved in the processing of placing ads and using the ads. And what Seismic is doing, basically, it provides a unified system for the advertisers to run all their advertising-related activities. When I say advertising-related activities, it's a wide range of activities, from building the ads, to traffic the ads, to put the ads on sites, to measure the performance of the ads, to optimize, to evaluate, many different activities that involve many different companies that the advertisers work with, and Seismic tries to consolidate that and bring basically one view to these advertisers. And basically, we call ourselves, we are an open ad management platform, which is basically a platform that deals with all these different data points and data elements and provides a consolidated view to our customers. If we talk about the scale, it's a global company. We have thousands of agencies, and what's more important in terms of scale, we talk about over 200 billion ads that are served on a monthly basis, and more than 100 billion bid events, which are basically decision points that our servers need to do on a daily basis. This is a huge scale. Over that data, we need to provide our advertisers with information about all different kinds of metrics, starting from simple analytics of how many ads were served, how many bids were done, what was the win rate, and where were they served, and also more complicated stuff like unique users that were exposed to our ads, and so on and so forth. But what makes it also really challenging is, since we work with so many different vendors, our clients treat the data in Seismic as the system of record, or the single source of truth. Therefore, the expectation from Seismic is to provide the data very accurately, consistent among the different channels, among the different vendors, and the data they see from the different vendors. And our challenge is, how can we build such a system? So we know that there are systems that can build that way, but we wanted to build it in the cloud, leveraging the cloud infrastructure, and see what would be the impact in terms of time to market that this can be built, and also implications of cost and other methods. Before we start, these were core principles that are expected from our system by the customers, the advertisers, basically, that use the data. First, they want this to be the system of record. So we are expected to collect the data from all the different sources in different formats, in different structure, store it in our single place, and provide consistent analytics on top of that. Of course, it's multi-channel, because we get it from different channels. We get it in different time zones, which is the global scale. So we need basically to provide analytics on different, even if you look on a day range, we want to see what was yesterday. Yesterday is defined differently in Israel, in the US, in Europe, and in the Far East. So we need to provide that global scale with a different type of analytics for each of the different locations, as also, as a side note, also accommodate the different privacy concerns that each of the global locations may have. And the fourth principle, we want the system to be open, which means that not only we can work with different providers in terms of ingesting the data, but they can also pull the data in any way they want using our API. Here are some considerations from a technical perspective. So, of course, one of the things we learned early on is that it's very hard to plan. When I remember back, I think it was end of 2010, we tried to do a prediction of how much data we'll have to handle by end of 2011. And there were discussions if it will be, we said, okay, if we'll get to 1 billion a month, that's already decent scale. We ended the year with doing 1 billion a day. The pace of change is very high, and we don't know what to expect in terms of scale and data we get it. So therefore, we have to build a system that scrolls horizontally. So whenever we get more data in, we just add more machines. Of course, we want to allow for low latency. Clients expect to see results in real time, very fast, don't have time to wait, not for the data to come in, not being showed in the reporting. System needs to be fault tolerant, so we cannot allow any downtime. High throughput, and more important here is the interactive analytics. Clients want to interact with the data interactively, and of course it has to be cost aware. We could build large racks of machines, have them everywhere in the world and probably be very fast, but this is not cost beneficial. So the system has to be cost aware. The question is, how are we going to do that? One of the things, before we go down into looking of how the system is built, one of the things we were challenged with is that in order to allow for fast analytics with low latency, we could use aggregation, but it's not useful for all of our use cases. I'll give a few examples of data that cannot be aggregated. For example, when we do unique counting, or basically where want to count how many individual users were exposed to the ads. So imagine that today we were exposed to 100 users, and tomorrow to another 200 users as well. So we probably serve a total of 200 impressions, 200 ads. But it's not necessary that we expose to 200 users, because there might be a big overlap over these users. So this is a metric that cannot be aggregated or pre-calculated on different dimensions. So that would be one of the examples of how we can calculate the data in a low latency with interactive analytics for the benefit of our clients. So here is a high-level schema of the system that we built. So you can see on the left side, we have different data providers. These can be either internal data providers like our systems that send the logs. It can be operational data provider of the logs of the applications that we're running. And they can be data providers that we work with that provide data either in a streaming mode, like we have partnership with other clients that also serve data and send us the data in real time, as well as batch type of data feeds that we get in. What we have then on the left side is we have a data in API. Basically, this is an API that is built that everyone that wants to ingest data in has to go through that API. I'll discuss in the next slide a few items about what are the principles of this API. But basically, we expect everyone to get the data in. There are some constraints about the format, but we try to keep it as open, as generic as possible. What happens then is the data goes through a streaming processing engine. We talked about that, several talks before talked about that. Basically, this component serves two main functionalities. One is data enrichment or completion, where sometimes we get through the logs only partial amounts of data, and this system is in charge to fill out data that is missing. I'll give an example. Sometimes you get customer ID that gets in. You will not send the customer name on each log. It may be that this layer would complete the customer name, for example, or look up between IP address and geographic range. So we have here a system that gets the data in a streaming mode and does various tasks of data enrichment and completion. And it's built in a way that we have plugins that plug into that system, and every plugin is responsible for some type of activity of completion, enrichment, and so on and so forth. And at the end, the data is then written to a raw data store. This raw data store is the single point of truth that we call. So once the data gets into that system, this is where the data is kept for a long period of time, and we'll talk about that a bit later. And the data is there for any type of analytics to be used later on. You can see the arrow there, which means that I made a slight simplification when I said this is the single source of truth, because sometimes the data comes in and there are some enrichment or some processing that is needed that may require some time, that is time consuming, that cannot be done interactive immediately. So what happens is there might be a few tiers here of data that is there. At the end, there is one single source of truth. There might be different SLAs on the availability of all data points. So let's say eventually by the end of the day, everything there is full and complete. There are items that are ready earlier than others. It depends on the availability of the processing. On top of that, we can already run heavy lifting queries like MapReduce, like other batch processing. But there is also a layer of interactive analytics on top of that. That layer, in order to work consistently, we wanted this layer to run on top of the raw data. So by saying raw data means we don't want to keep aggregations, because when we do aggregations, this is where the data may become not out of hand, but start to become inconsistent with other analytics that people see. And we wanted to be able for all clients to get access to the data and run the same queries or get the same results. So therefore, we kept the data in the raw format. So whenever you run queries on the same data, you get the same results. On top of that, we have the data out API, which is where the data is queried from the system. And basically, that data out API can work with any of the data layers. So the data out API can call the interactive analytics for an interactive application. But say we have some customer that needs a feed of data or that doesn't require interactive analytics, that system goes to the appropriate store or to the appropriate medium to pull the data out in the format that the customer is interested in. And on top of that, we have the visualization. So a few considerations in terms of how to build that system, that we used at least. We kept the data in JSON all the way through. And basically, also, it's not only that we kept it in JSON, we kept it in the same format. So we tried to use the same data format, the same data scheme, basically, in all systems. So when someone writes a query, it's the same if you write it to an interactive database as opposed to if you write it for a batch or for a system that takes longer time. As long as the data is consistent, the query looks pretty much the same. The second principle is to keep it all elastic. Everything, every worker, every component is fully self-contained, so it's fully elastic. And what we also did is that when we saw the plugins in this scheme, basically some of the plugins can be plugged in also in any other engine later on, so we can do the same analytics, the same processing also in other tiers if needed. In order to allow for both horizontal scale and low latency and interactivity, we partition the data by accounts. So as mentioned, we have thousands of accounts, and while the data is huge, we talked about over 200 billion ads that we serve in a month, or over 100 billion requests we make on a daily basis. When you partition it by account, this gives the ability to run on a still huge numbers, but at least at a bit smaller scale. And by that, we give different levels of flexibility to the different accounts, both by performance, but also, and this is the next point, by tiered storage. So in order to allow different SLAs, or in order to allow different clients to get results in different time frames, we used different layers of storage. So there are SSD drives that could be used on the high end to provide very low latency for the ones that care, and we can load their full data into that. There might be other clients that are interested only for a certain period of time, let's say the last 30 days or whatever, so we could keep that in different storage. So this is very important that we keep it partitioned by the account, so we can provide each account with resources that will fit their needs in terms of latency, time range, etc. And as mentioned before, we run always on the full data on that single point of truth. So for the ESP, I'll go through the main architectural point for each of the components in the system. So the ESP, which is the event stream processing, usually what they do is they do the lookups, which is relatively fast. Again, it's the same schema. And the plugins that we built there are built in a way that they can run also in that batch analytics. The reason for doing that is sometimes, and I'll talk that later, we had, for example, big backlogs. If you have big backlogs that you process all at once, sometimes it's more useful to run them in a MapReduce environment, and they can be plugged into that MapReduce and do the same faster. So that's why we kept it that way. And also, we added auditing to trace the stations that each data point goes through. This is very important, especially if clients ask if something doesn't look like they were expecting it to look. In terms of the batch processing layer on top of on the raw data store, the way we did it is we divided that into two batches. One is for the event processing or data enrichment before the final data is written. So, for example, if you want to analyze each page that we got into the system, crawl that page, do some analysis of that page, this is obviously a time-consuming task. By saying time-consuming, it can take a few seconds. So, but this is not something you want to do in streaming, but this can be done in a batch processing before it's written to the main store. But there is another type of batch processing, which is already analytics, that is ad hoc querying, that the latency is not that important, that you run on top of MapReduce, Hive, whatever you use. So, and sometimes you also create aggregated reports by that. So that's the second phase. As mentioned before, we also use some tiered storage in that S3. Some of them is temporal storage. And again, it's also a JSON account level and so on. For the interactive query system, it's basically the same principles, tiered storage. We try to do most of the calculation logic at query time, so this gives us the flexibility to accommodate models, to build new models without reprocessing the data. So as much we can shift to the query time, the better. And also we don't need to load all the data to the query layer because this is more expensive. So based on the needs, we can load the data and unload it. And again, JSON account level participant. The implementation we did, I'll briefly talk about it. We did it on the AWS cloud. We used Kinesis as the ESP. We did two modes of one, the workers we built them ourselves based on Amazon workers. Also, There is another model that we did with Spark. We used S3 as the raw data store and Redshift as the interactive analytics. We had MicroStrategy or Tableau running on top of that data just to provide some visualization. And of course, we used EMR for the batch. We did end-to-end, it's not a full system, it's an end-to-end system within 6 weeks, where the system did ingested all the data and processed it and provided a few queries, the most complicated ones like unique user counting, geo breakdown, and different type of analytics. This is the illustration just with the Amazon components. I give you just a glimpse of what type of infrastructure was needed. You can see the type of instances. It's not huge. And the cost is reasonable if you compare that to what would be required to have a system on-premise that does it with all the data load and accommodate for spikes. It's within reasonable pricing. So what worked? We learned that the infrastructure is solid and flexible end-to-end. And we surprised ourselves in the time, the time frame we were able to build the system time to market. We felt the flexibility and the agility that we could make experiments with one solution, take it up and down, process backlogs. There is benefit of having all the data in the cloud, and you need to make the right calculations so to keep it cost efficient, because it can easily go out of hand in terms of budget. What didn't work, where we had some challenges, is there's still, at the time we started, there were performance tuning that needed to happen. It's one of the largest scale systems that was used in these environments. The transition from streaming to batch, that area had some challenges in terms of optimization, but still we're able to overcome that. And most important, keep your finger on the pulse in terms of budget. Make sure that you manage that wisely and don't run out of budget. In a nutshell, so I think for us, it showed that processing billions of raw data events daily is possible. Just keep in mind that in aggregate, we have hundreds of billions of events. It works interactive, it works fast. The cloud removes the limitations on infrastructure and time, just to set it up. But data architecture and data cost is key. You need to be sure you allocate the data the right way. So when you play with it, you have that flexibility. So that's it. And as all other companies, we're also hiring. So feel free to shoot. Yeah.